Hello, my name is Sergey Gorodetsky, and I'm an associate professor at Moscow Institute of Physics and Technology at the Department of Higher Mathematics. Today we are going to consider problems of physical mathematical contest that is called MIPT, that is Moscow Institute of Physics and Technology International, the contest that took place at the beginning of December 2019. And we're going to solve these problems and we'll consider one problem set that was written by 9th and 10th grades, and later on we'll consider one more problem set for the 11th grade. And now we are starting with a problem set that was offered to 9th and 10th grades. And here you can see the first problem on the screen. So we're given like a text problem. We have two types of cast iron, and percentage of chromium is different in them. And now we mix them in different proportions and get to different alloys. So what do we have here? I suggest that we denote the percentages of chromium in both types of cast iron as variables. So let's say that percentage of chromium in the first alloy is equal to alpha, and in the second alloy is equal to beta. And we know that if we take equal masses of these two types of cast iron, we're going to get an alloy that contains 12.6% of chromium. For example, if we have taken M of the first alloy and M of the second, how much chromium is there in the resulting alloy? There is alpha times M divided by 100 chromium in M kilograms of the first alloy, and there are beta M divided by 100 kilograms of chromium in M kilograms of the second alloy. And we know that the total mass is equal to 2M, and the percentage of chromium here is 12.6. So it is a mass of chromium calculated in the whole alloy. Now we can reduce both sides of this equation by M divided by 100. And so these elements are reduced from here. And we get an equation that alpha plus beta is equal to 25.2. Now let's consider the second condition. If we take the two types of cast iron in the ratio of 3 to 2, what's going to happen then? It means that we have taken 3M of the first alloy, 2M or of the first type, 2M of the second type of cast iron, and the total amount of chromium in this alloy is going to be 3M times alpha divided by 100 plus 2M times beta divided by 100 as well. And we know that the alloy that we get as a result, it contains twice as much chromium as the first sort of cast iron. So here it is. the mass of alloy that we get is 5m. And we know that the percentage of chromium in the resulting alloy, so here, is twice as large as alpha. It means that percentage of chromium here is equal to 2 alpha. And so to get the amount of chromium, we need to multiply this 5m by 2 alpha divided by 100. And these results, they're equal to each other, as both the left side of our equality and the right side, they correspond to the amount of chromium that is contained in the alloy. We can also reduce this equality by m divided by 100. So on the left and on the right, these are common terms that are reduced, and thus we get that 3 alpha plus 2 beta is equal to 10 alpha. After that, the problem becomes, so to say, technical. We only need to solve a system of linear equations, and there is nothing special in here. We can express beta from the first equation, for example. So beta is equal to 25.2 minus alpha. And after that, we substitute this expression for beta into the second equation. By the way, in the second equation, we can move 3 alpha to the right first. And this way we get 2 times 25.2 minus alpha is equal to 7 alpha. Now I prefer to leave it as it is, so I can write down the answer that alpha is equal to 5.6, and that is the percentage of chromium in the first type of cast iron, and beta is 19.6 then. And that's it with the first problem, and now we move on to the next one. We need to solve the inequality. Here we can see that there are 2 fractions on the left, and the first and the second, they have something in common. That is, the numerator of the first fraction coincides with the denominator of the second, and the denominator of the first is similar to that of the second. Keeping that in mind, we can introduce a new variable here, so as the fractions are similar. And if t is equal to x squared plus 12 divided by x, that is our new variable. I think it's quite obvious that the second fraction, so 56x over x squared plus 12, is equal to 56 divided by t. Therefore, our inequality becomes t minus 56 over t is greater or equal than 1. After that, we move this one to the right, to the left, and we combine no like terms here. We just write everything under the common denominator. So it is t squared minus t minus 56 divided by t is greater or equal than 0. And the numerator can be easily factorized. We get t minus 8 times t plus 7 divided by t is greater or equal than 0. Perfect. Now we draw a real line. So the points where the numerator turns to 0 are 8 and minus 7. The denominator is equal to 0 at 0. And the signs of the fraction on the left are alternating. So here we have a plus, then a minus, plus, and minus. And we need pluses here. So these are the intervals that represent solutions of our inequality. But then we have to go back to x, and so we get 2 inequalities. The first one is when we consider this interval is that x squared plus 12 divided by x has to be in between -7 and 0. -7 is included and 0 is not. Of course, we can solve the left side and the right side separately and then intersect the sets obtained. But that's not very convenient here, and it's better to consider the right side of this inequality first. We can see that the numerator of our fraction is positive for all values of x, and therefore for the fraction to be negative we need its denominator to be negative. And so the right inequality yields that x is less than 0. But if x is less than 0, then both sides of the left inequality can be multiplied by a negative x. And so the left inequality yields -7x is greater or equal than x squared plus 12. I have changed the sign of the inequality due to the fact that I multiplied it by the negative number. Then we're just facing a quadratic inequality, and so it is x squared plus 7x plus 12 is less or equal than 0. Therefore, x is in between -4 and -3. And that's it with the first case. And now we proceed with the second. The second is when x squared plus 12 divided by x is greater or equal than 8. Now from here I cannot say anything about x, whether it's positive or not. Maybe if we look at it, the inequality more carefully, we can deduce that x has to be positive. But if we just use the standard reasoning, we'll get it this way. We move 8 to the left, we write everything under the common denominator, and we have x squared minus 8x plus 12 divided by x is greater or equal than 0. After that, the numerator is factorized. And we draw a real line, and in effect we make just the same actions as above. So here are the points 6, 2 and 0. After that the signs plus, minus, plus and minus, and we get to interval that satisfy the inequality. And so these are intervals from 0 to 2 and from 6 to plus infinity. And the final answer consists of 3 intervals indicated in here. Now we're ready to go on to the next problem, and the next problem was geometrical problem. So we'll need to draw a picture first. So we have a trapezoid, a circle, and we see that one of the legs of our trapezoid is a diameter of this circle. Maybe it's reasonable to start drawing everything with a circle. So we have a circle. After that we have a diameter, and it is in fact leg CD that is a diameter. Then another leg is tangent to this circle. At some point. So this leg AB, it is tangent to our circle, and it is perpendicular to the bases of the trapezoid. So we'll get the bases if we drop perpendiculars from points C and D onto the line that contains this leg AB. So we have this line tangent to the circle, and we drop perpendiculars from C and D onto it. So they are A, B. Maybe it's better to denote, the point of tangency is called L, and let us also denote the center of the circle as O. Then we know that BC is 5, AD is 8. And we have to find the distance from L to CD. That is the length of this perpendicular. All right, now I've been drawn a picture. Now we can start reasoning and solving the problem. All right, what can we see here? I think the first thing for us to do is to connect points O and L. So O is the center of our circle, OL is its radius, and as leg AB touches the circle, the radius has to be perpendicular to it. So here we have a right angle. Furthermore, we can notice that O is the midpoint of CD, and OL is parallel to the bases of the trapezoid. Therefore, OL is the midline of our trapezoid, and so it is equal to 1/2 of the sum of BC and AD. And thus OL can be found. It is 8 plus 5 over 2, that is 13 over 2. Then CD is a diameter, and so it is twice as large as the radius, and therefore CD is 2 times 13 over 2, and it is 13. Now if we know three sides of a trapezoid with the right angle, so if the right trapezoid, the trapezoid is determined uniquely by this data, and we can find everything we need. Now let's look more intently at what we'd like to find. We'd like to find this distance. Let me call this point H, for example. And this distance LH can be found from the right triangle LOH. What do we need for it? We need to know either two sides of that triangle or one side and one angle, one acute angle of this triangle. We already know OL, so it is a radius. Then we need either OH, and that is not that likely we're going to find it easily, or we need to find some angle of this triangle. But due to some lines OL and AD being parallel, we can see that these triangles are equal to each other. And so let's call these angles for beta. So this is beta, and beta is an acute angle of the trapezoid. To find it, let's drop a perpendicular from vertex C on the greater base of the trapezoid. So let it be P. So CP is a perpendicular. By the way, point P lies on the circle, as CD is a diameter. The angle CPD has to be a right angle, so it is inscribed into the circle, and therefore diameter subtends right angle at point P. Then we can find that DP is equal to difference of bases of our trapezoid, that is 8 minus 5, that is 3. Then Cp, it is the altitude of our trapezoid, and it is equal to 13 over 2 squared minus dp squared, that is 3 squared. Let's see how much we get here. Oh no, something is a bit wrong here. It is not 13 over 2, it is just 13. So CD is equal to 13. So it is root of 160, so it is 4 roots of 10. And now we can see that sine of beta is equal to Cp over Cd, and it is 4 roots of 10 divided by 13. And now we can find HL from the triangle, OHL. So HL is equal to OL times sine of beta, and it is 13 over 2 times 4 roots of 10 divided by 13. And we get 2 roots of 10 in the end. And that's the answer to our problem. Now we're ready to go on. And the next problem, we're facing it right now. In fact, it wasn't that difficult. So you have like half a minute to read it. And let me write down the condition here. So he goes to the movies every every third day, to concert every fourth day, and to a museum every 11th day. And so we call days for cultural if he goes to a museum and to a concert, but not to the movies. Then we have to calculate the number of days when he visits all 3 events first, so both movies, concert, and museum. How often does it happen? So he goes to the movies every 3 days, to a concert every 4 days, and to a museum every 11 days. But numbers 11, 4, and 3 are co-prime. That means that their largest common divisor is equal to 1. And therefore, he is going to visit all 3 events only once in 3 times 4 times 11 days. And it is equal to 132. So he visits all 3 only once in 132 days. Totally, there are 1056 days. If we divide this number by 132, we'll get a bit surprised, but it is divisible, and we get an integer result. It is 8. And so it means that during the period of 1056 days, there are only 8 days when this young man visits all 3 events. But such days, they cannot be called cultural for where determined cultural days as the ones when he doesn't go to the movie. And what do we have to do now? Now let's try to find how many days there are when he goes to a concert and to a museum. These two numbers are co-prime as well, and their least common multiple is 44, and therefore he visits concert and museum once in 4 times 11, so once in 44 days. That is, there are 1056 divided by 44. It is exactly 3 times greater than the number above. For the numerator, here was 3 times greater than here. And so it is 24. So there are 24 days when he goes to a concert and to a museum. Out of these 24 days, there are 8 days when he also visits the movies. It means that the quantity of cultural days is equal to 24 minus 8, so it is 16. And that's the answer to this problem, and in fact there is nothing special to it. And now we're facing a system of equations. In fact, not that difficult system, but one has to be careful in calculations in order not to make any calculational mistake, for numbers become quite big here, quite large. And what is the way to start it? We can solve this system in different ways, of course. So there is not like some single path one has to abide to, but different possibilities. Yet I think the most simple way to deal with it is to add all 3 equations together and then divide the result by 2. If we add all 3 equations, we can see that each of the roots is encountered exactly twice on the left, and so when after adding we divide everything by 2, we'll get root of x plus y plus root of y plus z and plus root of z plus x. So that's going to be the left side. As for the right side, we only need to find this amount, so it's going to be 22 plus 17, that is 39, and plus 24, 63. That's the result we get. And now it's better to subtract each of the initial equations of our system from the one we obtained. We can see that if we subtract the first equation from the one written here, we'll get that root of z plus x is equal to 19. After that, we subtract the second equation from it, and we'll get that root of x plus y is equal to 29. Finally, we subtract the last one, and it yields that root of y plus z is 15. The next step is, I think, obvious here. We only need to raise both sides of each of the equations to the second power. And so we'll get that z plus x is 361, x plus y is 841, and y plus z is 225. And after that, we can repeat the same procedure. That is, we can find the sum of all of the equations and divide it by 2. This way we'll get a sum of x plus y plus z, and we'll only have to subtract each of the equations of this system from the one we'll get this way to have values of x, y, and z determined. And so let's see what we have here. The sum of all of the equations divided by 2 is going to give us x plus y plus z on the left and 713.5 on the right. After it, we subtract the first equation from this one, and we get the value of x. And we see that oh no, I'm sorry, we get the value of y. So subtracting this equation from here yields us a value of y, and we see that y is equal to 352.5. Then we subtract the second equation from it, so we need to subtract 841 from 713.5, and we'll get that z is equal to minus 127.5, and finally subtracting the last equation is going to give us the value of x, and that is 488.5. Now we are facing a geometrical problem. We have a quadrilateral inscribed into a circle, and diagonals of our quadrilateral are equal to 14 and 48 respectively, and the radius of the circle is also known, and it is given here, it is 25. The angle between the diagonals is 60 degrees. And so first I'd like to notice that knowing the radius of the circle and the length of its chord, we can find the distance from the center of the circle to this chord. Let me make a small picture first. So let's suppose that we have a circle and some chord inside this circle, and let it be equal to 48, and the radius is 25. We have an isosceles triangle here, so dropping an altitude of this triangle to the base of this triangle, we'll get that this altitude is also a median, and so it divides the base of the triangle into two equal segments of 24 each, and using Pythagorean theorem for any of these two triangles, we'll get that the distance from the center of the circle to the chord is equal to 7. In the same way, we'll be able to find the distance from the center of the circle to the chord, that is equal to 14. So if we have any chord that is equal to 14, then we'll get that here is 7, the right angle, the radius 25, and so the distance is going to be 24. All right, and now let's make a larger picture in order that we can see everything on it. I would also like to make the following remark. The angle between the diagonals is 60 degrees. If we drop perpendiculars from the center of the circle onto each of them, the angle between these perpendiculars is going to be 60 degrees as well. And it is reasonable to start making this picture with diameters that are perpendicular to diagonals. So let me draw a dashed line. So it is one of the diameters that is perpendicular to diagonal, that is 48. So our radius is 25, and we have to take a small piece that is equal to 7 here, and that is our first diagonal. After that, the diameter that is perpendicular to the second diagonal forms an angle of 60 degrees with the first diameter we have already drawn. And so drawing the second diameter yields us this picture. We have the angle of 60 degrees here. And, all right, it is our second diameter. Now we have to take a point at a distance 24 from the center of the circle on this diameter. And we draw a perpendicular to this diameter at this point. So it is our second diagonal. Let us name the vertices somehow. Let them be A, B, C, D. In the center of the circle, let it be O. The intersection point of the diagonals, let it be P. And maybe we'll also need the midpoints of diagonals. Let them be H and F. And I guess this intersection point, T. I think that's enough. Now let's look here. We have a right triangle, OTF, and we know one of its legs, it is equal to 7, and one of its acute angles, it is 60 degrees. But if this angle is equal to 60 degrees, it implies that TF can be obtained from OF by multiplying it by root of 3, square root of 3. Square root of 3 is tangent of 60 degrees. And thus TF is 7 roots of 3. As for OT, it is twice as large as OF, and so it is equal to 14. But if OT is 14, and we remember that OH is 24, we deduce that HT is equal to 10. The angle between the diagonals, we also recall that it is equal to 60 degrees. And now we also have a right triangle. It is PHT this time, and we know its acute angle P, 60 degrees, and we know its leg HT, it is equal to 10. So we can find its two other sides. The one that is PT is obtained by dividing HT by sine of 60 degrees, and it yields 20 divided by root of 3. And as for PH, it has to be 2 times less than PT, and thus we get 10 divided by root of 3. In fact, to determine the sides of our quadrilateral ABCD, we only need to know the segments into which diagonals are divided by their intersection point, that is P. Okay, we know diagonals themselves, we know the angle between the diagonals, but now, having calculated all these segments, we're able to determine the values of AP, PC, BP, and PD. And that would be sufficient for us. Okay, as for AP is equal to AH, and that is 1/2 of AC, and minus PH, but PH is already known. So what do we have here? AP is 7 minus pH. That is 7 minus 10 over root of 3. PC is just CH plus pH, that is 7 plus 10 over root of 3. Now, what happens with PD? We have that this one is 24, and so we have 24 plus 7 roots of 3 plus 20 divided by root of 3. And we'll have we'd better bring these two under common denominator, and it is 21 divided by root of 3 plus 20 divided by root of 3. It is 41 divided by root of 3. But having calculated PD, we now can find BP. In order to do this, we only need to subtract PD from BD. BD is equal to 48, and subtracting PD from it, we get that BP is 24 minus 41 over root of 3. And finally, we can find any side of the quadrilateral that we want. We need the smallest side of this quadrilateral, and I guess it is more or less obvious that the smallest side is AB. So that BP is less than PD, AP is less than PC, and this angle APB is an acute one, and so AB is going to be the smallest side. Now we use the law of cosines for triangle ABP to get the value of AB. Okay, AB squared is equal to AP squared goes first, then plus BP squared goes second, 24 minus 41 over root of 3 squared, and then minus 2 times AP times BP and times cosine of 60 degrees. 2 and cosine of 60 degrees are reduced, as cosine of 60 degrees is equal to 1/2. And now we're facing only a technical problem. We need to simplify this expression and extract a square root if possible. I won't waste time on it right now, and I'd better write the result straight away, so some technical work, and it yields 914 minus 527 roots of 3. So it means that AB is equal to 914 minus 527 roots of 3 and square root of it all. Curiously enough, it is possible to transform this expression a bit further, and it happens that the expression under the square root represents an exact square of the following expression. It is 1/2 of 31 minus 17 roots of 3, everything squared, and so it yields 31 minus 17 roots of 3 divided by root of 2. In fact, the last step was not obligatory to perform during the contest itself, so you could have done without it. But it may look quite weird, so it is not very easy to guess how to transform this expression into an exact square. In fact, I can tell you that there exists a formula that allows such transformation. So if we have something like this, a plus square root of b under the square root, there is a formula that looks this way. So it is square root of 1/2 of root, just a moment, a plus root of a squared minus b, and plus square root of 1/2 of a minus square root of a squared minus b. And so that's the formula, and obviously it works only if a squared is greater or equal than b. So in this situation, this formula is correct. Quite often it doesn't lead to anything, for if it happens that the expression under this root is not an exact square, then the right side is basically more complicated than the left. But it may happen that the expression under this inner root is an exact square, and in this case the whole expression we started with is simplified. So here on the left we have a square root under the square root, and on the right there is nothing of the sort, as this root can be calculated. And there is a very similar formula with a minus. So if minus is here, then we change this plus for minus. And this is also a formula one can use under this condition. And if one applies this formula to the square root we have obtained, one can get, yes, that this square root is transformed into such a difference. And that explains how we can guess that this expression is equal to the exact square we have written here. So the task seems to be quite complicated. It contains several statements, and all of them have to be taken into consideration, and it is important not to forget anything. So we have our set x that consists of different natural numbers, so that is the first condition. The least common multiple of all numbers from x is equal to 462. And I guess right now we can start solving it, can start undertaking something. When it is a question about the least common multiple or the largest common divisor or something like that, the idea is, that is used quite often, that we need to factorize the numbers. So it is an integer, and it can be represented as a product of prime numbers. So 462 is factorized as 2 times 3 times 7 times 11. And all numbers from x have to be divisors of 462. Okay, it means that we're going to have, what numbers can we have here? We can have 1, we can have 2, 3, 7, 11. So these are the numbers that have exactly one of these factors in them. Then we can consider numbers that have two factors, that are 2 times 3, 2 times 7, 2 times 11, 3 times 7, 3 times 11, and 7 times 11. There are numbers that contain 3 different divisors: 2 times 3 times 7, 2, 3, 11, 2, 7, 11, and 3, 7, 11. And finally, there is one number that contains all 4 of the divisors, that is 462 itself, of course. Okay, and so this condition that the least common multiple of all numbers of x is equal to 462 tells us that we cannot use any numbers but for the ones listed here. Let's move on to the next condition. The product of all numbers of x is a multiple of 7 to the power of 7. Okay, so it's a good idea that we consider those numbers from here that are divisible by 7. How many of them are there? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Yes, that means that we need to take at least 7 of these numbers so that the product of all numbers from x is a multiple of 7 to the power of 7.
Пока просто отсюда продолжается.
Какая грусть, а?
Вот прям вот с этой мысли пока продолжается.
By the way, it's obvious that if we take at least 7 of the circled numbers, then the least common multiple of them is going to be equal to this product. So if we take at least 7 of these numbers, we'll get at least one factor of 2, at least one factor of 3, and at least one factor of 7. And therefore, the common multiple cannot be smaller than this one. Okay, and so this condition with the least common multiple is fulfilled. All right, and we can move on. As we have said, we need to take at least 7 of these numbers that are circled with green. Let's think if we can take all 8 of them. What happens then? If we take 8 of these numbers, we'll get that the product of these numbers is equal to what? It is equal to 7 to the power of 8, as 7 is contained in all the numbers. Then 3 is encountered 1, 2, 3, 4 times, so we'll get 3 to the power of 4. But it's easy to check that 2 is also to the power of 4 and 11 is to the power of 4. And that is an exact square. But we know that the product of all numbers from x is not an exact square. Therefore, we cannot take a set such that it consists of 8 of these circled numbers. But there is some possibility that we can add something to this set. But we are also told that neither two numbers of x are co-prime. So for each two numbers we consider, their greatest common divisor has to be greater than 1. But we can see that if we have all 8 of these numbers in our set, we can't add anything without violating this condition. In fact, 7 is co-prime with all the numbers that are not circled. And whereas we have this 7, we cannot add anything to our set. So it means that if we have 8 numbers, we cannot satisfy the task. Thus, it implies that we have to restrict ourselves to 7 numbers out of the 8 circled. Let's see what's going to happen then. If we take any 7 numbers from the ones circled, and that is also we do not add anything else to them, then the 7 numbers considered form set X that satisfies the task. Indeed, the power of 7 is not going to be even. So if we take 7 of these numbers, the product of them will yield 7 to the 7th power, and therefore it cannot be an exact square. And so any 7 numbers from the one circled satisfy the task. But we can also try to add something else to 7 numbers chosen this way. But the fact is that we can add something only in case we get rid of this number, if we get rid of 7. I hope you remember that while we have 7 in our set, we cannot add anything else to it due to the condition that neither 2 numbers of x are co-prime. So while we have 7, all the other numbers that are not circled are co-prime with this 7 and cannot be added to the set. And so the only way, the only situation when we can add something to our set of 7 numbers is when we have numbers 2 times 7, 3 times 7, 7 times 11, 2, 3. Seven, 2, 7, 11, 3, 7, 11, 2 times 3 times 7 times 11. So these are 7 numbers from here. And if we consider this set, the only number that can be added to this set is this one if we do not want to violate this condition. And so it is 2 times 3 times 11. And that's the 9th possibility to form X. To sum it up, either we take this set that consists of 8 numbers, or we take any set that consists of 7 numbers of the ones circled. And that's the end of all the problems of the contest. So we considered all the solutions, and I'd like to thank you for your attention and wish you luck in the future.